Hello everyone, let us do revision exercise 5 based on mensuration. Here we have the first question. Question is find the area of the following shape. Okay, now here triangle is given. In case of triangle, area we can find out by the formula half times base into height, or it is half times your two sides, that is 8 and 7 given here, into sine of angle between them. So 1 by 2 times sine 8 into 7 into sine 30 degree. Okay, so here your area will be 1 divided by 2 times 8 times 7 times sine 30 is 1 divided by 2. So 8 divided by 4 is 2, 2 times 7 is 14. So area of the following shape is 14 centimeter square. So your area is 14 centimeter square. Let us go to the next problem. Here we have a trapezium shape, and for trapezium shape your area is 1 divided by 2 times sum of parallel sides. So here parallel sides are 7 and 11 into distance between the parallel sides, which is 6. So your area is 1 by 2 times 7 plus 11 is 18 times 6. So here it is 9 times 6, which is 54. So 54 centimeter square is your area. Now next, here we have a parallelogram. We have to find the area. Now for parallelogram, your area is base into height. Base here is 10 centimeter and height is 5 centimeter. Okay, two sides are given, 10 centimeter and 6 centimeter, but distance between parallel sides, which we can consider as height, is 5. So for this height 5 centimeter, we can consider base as 10 centimeter. So here your area will be base, which is 10, times height, which is 5. So 50 centimeter square is your area of the parallelogram. Okay, why they have given this 6 centimeter? Okay, they have given this 6 centimeter to check whether you will take 6 centimeter or 5 centimeter. Next question, here we have a kite. Find the area of the following shape. Now from here the longest diagonal is given 9 and the shortest diagonal is given 4. Now this shortest diagonal is perpendicular to the longest diagonal. So as they are perpendicular to each other, here area will be, what you can do, if you don't remember the formula, you can divide this whole kite in two triangles. So area of triangle is half into base into height. So here you can consider this height as 2 centimeter and this height as 2 centimeter. So your formula for area is half times base, we can consider 9, times the height, so 2 centimeter here, and for the other triangle also it is 2 centimeter, so we can say 4 centimeter. That means in case of kite we can use formula as half into longest diagonal times shortest diagonal. So this will give you result as 9 times 2, which is 18 centimeter square. So this is your first question, where you have to simply find out areas. Now let us move to next question. So question number 2, question number 1, okay. Question number 2, a circle has radius 9 meter, find its circumference and area. The circle has radius 9, find its circumference. So the formula for circumference is 2 pi r, which is 2 times 3.14 times your radius, which is 9. So here your circumference, you can use the value of pi as given in your calculator. So 2 times pi times 9. Okay. Let me check if this exercise is without using calculator. Yes, it is without using calculator. Only question number 1 is without using calculator. So question number 2, here you can use calculator. So I can use the value of pi which is given in calculator. So the result is 56.55. 56.55 centimeter. This is not centimeter, it's meter. 56.55 meter. Okay, you can round it up to 1 decimal place, or we can see that in 3 significant figures it is 56.6 meter. Next, find its circumference and area. Okay, next I have to find out area. So area is pi r square. So here value of r is 9, value of pi we will take 3.14 or calculator. So this gives me answer as 254.469, that is 0.5 or 0.46, I will say 0.46 meter square, and when we round it up to 3 significant figures it is 254 meter square. So your answer is 254 meter square. Next question. A circle has circumference 34 centimeter. Find its diameter. So circumference is already given. That means 2 pi r, that is pi d. Pi d value is given, which is 34. So therefore your d will be 34 divided by pi. 34 divided by pi will give us 10.82. So 10.8 I will consider. 10.8 centimeter is your diameter. The circle has area 50 centimeter square. Find its radius. So now area is given, that is pi r square is given, which is 50. So therefore r square is 50 divided by pi, and therefore r is square root of 50 divided by pi. So your square root of 50 divided by pi, 50 divided by pi will be 3.989. It is 3.989. So this we can consider as 3.99 unit will be centimeter. So your radius, here radius is 3.99 centimeter. Next question. Question number 3. A target consists of concentric circles of radius 3 and 9. Find the area of A in terms of pi. Okay. So inner circle has radius 3. So find the area A in terms of pi. So your area A will be equal to pi times 3 square. So which is 9 pi. Unit will be centimeter square. Area of A. Find the area of find the ratio of area of B to the area of A. Now B, if you see, it is this shaded part. Find the ratio of area of B to the area A. Okay, so B is your shaded part. Let me see once again. Target consists of concentric circles of radius 3 and 9. Find the area A in terms of pi and ratio of area B to the area A. Now here there is little confusion whether we consider B as the whole circle or we consider B as the shaded area. Okay, I believe I will consider B as the shaded area. Okay, give me 1 minute. I'll be back. Okay, so here find the ratio of the area of B to the area A. So for that, let us first find out area of B. So your area B will be equal to your area of this bigger circle, which is pi times 9 square, minus area of this inner circle, which is pi times 3 square. So here this is 81 pi minus 9 pi. So 81 minus 9, it is 72 pi. And therefore area of B divided by area of A ratio will be equal to 72 pi divided by 9 pi. That gives you 8 ratio 1. 8 upon 1. 8 ratio 1. Okay, so your ratio of area of B to the area A will be equal to 8 divided by 1. 8 ratio 1. Fourth question. Figure 1. A circle of radius 4 is inscribed in a square In figure 2, a square is inscribed in a circle of radius 4. Calculate the shaded area in each diagram. Okay, very good question. Now let us first concentrate on this first figure. Okay, in first figure, radius is given 4 and it is inscribed in a square. Okay, so if radius is 4, its diameter will be equal to 8 and therefore side of this square will be equal to 8. Okay, so if I subtract area of circle from area of square, I will get area of these parts. Okay, that means 4 times of this shaded part will be the remaining area, and I want only this one part. So here, for your first question, for figure 1, if I say area of shaded region, okay, so required area will be 1/4 of your area of square, which is 8 square, minus area of circle, which is pi times 4 square. So if I convert this in decimal, the result will be 8 square minus 16 times pi. So the result will be, and that divided by 4. Yeah, that divided by 4. So your result will be 3.43. 3.43 unit will be centimeter square. Okay, so this is for figure 1. For figure 1, your area is 3.43. Now for figure 2, now for figure 2, a square is inscribed in a circle of radius 4. Okay, so here also radius is 4. Now here, if radius is 4, this diagonal of the square will be of length 8. Now I have to find out area of this shaded part. So again, what we can do, we can subtract area of square from the area of circle. Now if I draw diagonal like this, then these two diagonals are perpendicular to each other. And therefore, as in case of rhombus, we have area as half into product of two diagonals. Here for square also we can use that. So therefore, area of the shaded region, again here I will say that required area, your required area will be equal to 1/4 of area of circle, which is pi times 4 square, minus area of this square, which is half time your diagonal 1, which is 8, into diagonal 2, which is again 8. So this is 16 times pi, 16 times pi minus 64 divided by 2. The whole result I will divide by 4. So 4.566. 4.566, that is 4.57 centimeter square will be your required area. So in both the figures, you have radius 4. Okay, but in one case you are getting shaded area as 3.43, in other the area of shaded region is 4.57. Okay, now let us move to next problem. question number 5. Here question number 5 is given that OA is equal to 10 and your angle AOB is equal to 70. You have to find the area, you have to find the arc length AB. Okay, so arc length AB, I will say that arc length AB will be equal to 70 divided by 360. It is fraction of angle at the center times your 2 pi r. Okay, so 70 divided by 360 into 2 pi r is 10 centimeter. So 70 divided by 360 into 2 into pi into r is 10. So the result will be equal to 35 divided by 9 pi. So 35 divided by 9 pi is equal to 12.217, which is equals to 12.22, or I will say that 12.2. Here arc length, so it is centimeter, 12.2 centimeter. The second question is the area of a minor sector AOB. So area of a minor sector. Second question is area of minor sector. Okay, so here for length we are taking fraction of angle at the center times total length, which is 2 pi r. Similarly for area we will again consider fraction of angle at the center times total area, which is pi times r square. Now r is 10, so 10 square. So the result will be 70 divided by 360 times pi times r square, which is 100. So result is 61.08. So I will say that 61.1 centimeter square. So for question number 5, your arc length is equal to 12.2 centimeter and your area will be 61.1 centimeter square. Okay, now let us move to question number 6. The point x and y lie on the circumference of circle of a center O and radius 8, and angle XOY is 80 degree. So let us draw one circle, one center here, and your XOY, this angle will be 80 degree at the center. Calculate the length of minor arc XY. So length of minor arc XY, length of arc, minor arc I will say, XY will be equal to fraction of angle, which is 80 divided by 360 times total length, which is 2 pi r. So r is 8 centimeter, so it is 80 divided by 360 into 2 into pi into r, which is 8 centimeter. Okay, so this gives you result as 11.2 centimeter. 11.2 centimeter. Okay, it is rounded up to 3 significant figure. The length of chord XY. Now let me join this XY. Length of this chord XY we need to find out. Okay, for that what we can do, we can draw one perpendicular from this center O. Okay, now this perpendicular will divide this opposite side as well as it will divide the angle at the center. Okay, so as it divides angle at the center, here at center we have angle 40 degree on one side, 40 degree on other side, and this radius I already know, this is 8 centimeter. So if I apply trigonometry and I say that sine of 40, so your sine 40 degree will be equal to xy is there, xz I will consider, so it will be equal to xz divided by your 8 centimeter. So therefore your xy is 2 times xz. Okay, so I will say that xy is equals to 2 times xz will be 8 times sine 40 degree. Okay, so 2 times 8 times sine 40, 8 times 2 is 16, 16 times sine 40. So the result will be 10.3. Result will be 10.3. Length is in centimeter. So 10.3 centimeter is answer for question 6b. Now next question. The area of the sector XOY. So for area, this is your question A, this is your question B. Now question C. Question C is area. So your area will be area of sector XOY. Area of sector XOY is equals to, again it is fraction of total angle at the center times your total area of circle, which is pi r square. So this gives you result as 80 divided by 360 times pi times r square is 80 square. So it gives you result as 44.68, that is 44.7. So result is 44.7 centimeter square. This is area of sector, C part. Now D part, area of the triangle XOY. So area of the triangle, I will use trigonometry. So let us consider D part. Let me remove this answer for A and B. And for question D, area is half times A B into sine C, that is 8 times sine of 80 degree at the center. So two sides and angle between them. So our two sides will be 8. So it is half time 8 times sine of 80 degree. So your result will be 31.5. Your result will be 31.5. So D, area of the triangle. So it is 31.5 centimeter square. Now E part, the area of the minor segment of the circle cut off by XY. So this minor. Okay. So it is area of sector minus area of triangle. So here your area of minor segment, area of minor segment is nothing but area of sector minus area of triangle. So area of sector we get 44.7 and area of triangle we got 31.5. So your result is 44.7 minus 31.5. Your result is 13.2. Your result is 13.2 area. So its unit will be what? Its unit will be centimeter square. This is your question number 6. Now question number 7. Given that ON is 10, and minor arc MN is 18. So this minor arc length is 18. Calculate the angle MON. So your your length of minor arc will be equal to fraction of angle at the center times your total length, which is 2 pi r. So therefore x will be simply 18 times 360 divided by 2 pi r. R is 10. So your value for x will be 18 times 360 divided by your 2 times pi times 10. So your result x is 103.1. Okay, so your angle is up to 1 decimal place, so it is 103.1. Next question. A cylinder of radius 8 centimeter has a volume 2 liter. calculate the height of the cylinder. Now 2 liter. 2 liter will be equal to 2000 centimeter cube. So your volume, formula for volume is pi times r square times h. So your volume is 2000. This will be equal to pi times radius is 8 square times your height h. So this gives you your height h as 2000 divided by 8 times 8 is what? 64 pi. So 2000 divided by 64 times pi will be equal to 9.95 centimeter. Okay, so your answer is 9.95 centimeter. Ninth question, the volume of sphere of radius 6 centimeter. Calculate the volume of sphere. So for sphere, the formula for volume is 4 divided by 3 pi r cube. So 4 divided by 3 times pi into r is 6, so it's 6 cube. Result is 288 pi, that is 904.77. Okay, in 3 significant figures I will say that 905 centimeter square. B, the radius of sphere whose volume is 800. So volume is already given. That means it is given like this: 800 is equals to 4 divided by 3 pi r cube. I have to find out radius. So your r cube will become 800 times 3 divided by 4 pi, and therefore your r will become 800 times 3 divided by 4 pi, the whole power 1 by 3. So 800 times 3 divided by 4 times pi, and the whole power we have to consider 1 divided by 3. So 5.758. So 76 I will consider. 5.76 centimeter is your radius. So volume is 905 and radius is 5.76. Now let us move to question number 10. A sphere of radius 5 centimeter is melted down and made into a solid cube. Find the length of the side of the cube. So what is given? We have melted a sphere and made a solid cube. So here the volume of cube will be same as volume of sphere. As we are converting this sphere only into the cube, so their volume will be same. Okay, now volume of cube, the formula will be side cube, that is a cube, and volume of sphere will be 4 divided by 3 times pi r cube. And now for sphere, radius is already given to me and I have to find out the length of the side. So length of the side A will be equal to, here 4 divided by 3 pi r cube, we have to take its 1/3 power. Okay, so your answer for A will be 4 divided by 3 times pi times radius is 5, so 5 cube. So whatever result we get, we have to take its power as 1 divided by 3. This gives you result as 8.0599. That is, it will give you result as 8.06. So your A is 8.06 and unit will be centimeter. So 8.06 centimeter is your answer for question number 10. Question number 11. The curved surface area of the solid circular cylinder of height 8 centimeter is 100 centimeter square. The curved surface area of solid circular cylinder. Curved surface area, the formula is 2 pi RH. Okay, the curved surface area of the solid circular cylinder of height 8 is 100. Okay, so this 2 pi RH is given 100. We have to calculate the volume. Volume is what? Volume is pi r square h. So anyway, we have to first find out r. So here your r will be equal to 100 divided by 2 pi h. So this is 100 divided by 2 pi, and the value of h is 8. So the value is 100 divided by 2 times pi times 8. Result will be somewhere 1.99. Okay. But while calculating this pi r square h, I am not going to use 1.99. I am going to use the value which I get in my calculator. Okay. So this pi r square h will be equal to your pi times your r is in answer, r square, times your h is 8 centimeter. So you get volume as 99.47, that is 99.5 centimeter cube. This is up to 3 significant figures. So for question number 11, your answer is 99.5. Question number 12, a cone has a radius 5 centimeter and vertical height 10 centimeter. Corrected to nearest centimeter. Okay, calculate the maximum and minimum possible volume of the cone consistent with this data. Okay, so for maximum volume, I will consider upper bounds for all the dimensions. So I will say that V max, maximum volume. Now formula for volume is, we have formula for volume is 1/3 pi r square h. Okay, so here it is 1/3 pi. Now r radius is 5 up, correct, up to nearest centimeter. Okay, so 5. So if I have to find out the maximum volume, I will consider 5.5 centimeter. So pi r square, and height in place of 10 I will consider 10.5. So your Vmax will be equal to 1/3 times pi times 5.5 square times 10.5. Okay, so this gives you result as 332.6. 332.6 centimeter square. This is your Vmax. And V min, if I consider minimum volume, it is 1/3 pi. Now radius here is 4.5 square times your h. So here height we will consider as 9.5. So minimum volume we will consider 1/3 times pi times 4.5 square times 9.5. This gives you result as 201.45. So 0.45 I will consider as 0.5. So 201.5 centimeter cube. Okay, this is volume. So it's not square, it's cube. Okay, so you can see that if your radius and height are correct to one decimal place, your maximum volume will be 332.6, whereas your minimum volume will be 201. Now this 332, this will be rounded to 3 significant figures, and it will be 333 centimeter cube, and this will also be rounded. Initially we got as 201.45. So 0.45, if I round it to 3 significant figure, it will be 201 centimeter cube. So your minimum volume is 201 centimeter cube. Your maximum volume is 333 centimeter cube. Question number 13. Calculate the radius of hemispherical solid whose total surface area is 48 pi. Now for hemisphere, the total surface area is 3 pi r square. Okay, 2 pi r square is curved area and pi r square is one flat circular area. Your hemisphere will be something like this. This is your hemisphere. Okay, so this area is pi r square and this area is 2 pi r square. So your total surface area is 3 pi r square and this is given 48 pi. So from here we get r square as 48 pi divided by 3 pi. So this pi will cancel and 3 times 1, 3 times 1, 3 and 3, 3 6 are 18, 6, r square is 16 and this gives you r is equals to 4. So calculate the radius of hemisphere. So therefore radius is what? Radius is 4 centimeter. Radius is 4 centimeter. Question number 13. Question number 14 is calculate the area of equilateral triangle of side 6. For equilateral triangle, your angle at the center will be, or each angle is going to be 60. Each side is going to be 6. So I will use the formula as half AB, that is 6 into sine 60. So it is 0.5 into 6 times sine of 60 degree. So 9 root 3 and 9 root 3 in decimal it will be 15.588. So 15.6 I will consider, 15.6 centimeter square. The area of regular hexagon of side 6 centimeter. Now for hexagon, if you consider hexagon, this is how the hexagon is. Okay, this is not the perfect regular hexagon. Now here in this regular hexagon, what we can do, 1 2 3 4 5 6, what we can do, we can divide it in two rectangles, one rectangle and two triangle. Now this rectangle will have this length. Here the length is 6, this length is 6, this is 6, this is 6. Okay, and if I consider this angle will be for hexagon, each interior angle we will use the formula as 6 minus 2 times 180 divided by 6. This will be your each internal angle. So 4 times 180 divided by 6, that is 120 degree is your each internal angle. So this angle is 120. Now I can find out the area for this triangle 1, this triangle 2. Now for this 3, I need this opposite length. Okay, I need this opposite length. So for this opposite length, okay, this triangle can be considered as an isosceles triangle. So here triangle is somewhat like this. Okay, here this angle is 120. Okay, it does not seem as 120, but let us consider it is 120. Now if I draw perpendicular, so each angle will become 60 and your hypotenuse is of length 6. So sine 60, here sine 60 will be opposite length. So this opposite length, if I consider as x, so it is x divided by 6 and therefore x can be considered as 6 sine 60, and therefore this total height, let us consider this as h. So this h will be equal to 2 times 6 times sine 60, and therefore area of hexagon is sum of area of these two triangles, which is half times, so two triangles, I will say that 2 times half times, it is 6 times sine of 120 degree plus area of this rectangle, which is 6 times height is 2 times 6 times sine of 60 degree. Okay, so this 2 will cancel. So our answer is 6 times sine of 120 plus 6 times 2 times 6 times sine of 60 degree. So this gives you result as 54 root 3. 54 root 3 is 93.53, that is 93.5 centimeter square. Okay, so area of regular hexagon, we can divide this whole hexagon into triangle and one rectangle. If you know some better way, you can do by that. Okay, and see. So for A, the answer was 15.6, and for B, answer is 93.5. Let us do question C. The volume of regular hexagonal prism of length 10 centimeter, where the sides of hexagon is 12 centimeter. So now in place of length 12, length 6, now I have length as 12. So base area for C, let us first count base area. So for C, if I consider base area, so here base area will be, the formula is going to be same. Here it is 12 times sine of 120, plus here it is in place of 6 I have 12 times 2 times 12 times sine of 60 degree. So base area, we will see that it is 4 times what we have got. So 4 times of that is 374.1. This is your base area. Therefore, our volume of regular hexagon, your required volume is 374.1 times your height of the prism is 10 centimeters. So this time 10 will be equal to, so this multiplied by 10, it will give you 3741, and unit will be centimeter cube. So 3741 centimeter cube is your volume. Okay, let us move to next question. Question number 15. A cube of side 10 centimeter is melted down and made into an identical sphere. Calculate the surface area of one such sphere. A cube of side 10 centimeter. Now for cube, side length is given 10 centimeter. What we can say that volume of one cube, as it is melted, and from this we made 10 spheres, so it is going to be equal to volume of 10 times volume of sphere, volume of identical sphere or volume of each sphere. Okay, volume of one cube. Now volume of one cube is what? 10 cube, and 10 times volume of sphere is what? 4 divided by 3 pi r cube. What I have to find out? Calculate the surface area of one such sphere. So first let us find out what is r cube, what is r. So here your r cube value will be equal to, now this 10 and this cube will cancel and you have square here. So it is 100 times 3 divided by 4 pi. This is your r cube, and therefore your r is equals to 100 into 3, that is 300 divided by 4 pi, the whole power 1 by 3. So it's 300 divided by 4 times pi and the whole power 1 by 3. So your radius here, result is 2.879. Okay, no need to keep here in 3 significant figures, because we have to find out surface area. So your surface area, calculate the surface area of one such sphere. So required surface area Now the formula for surface area is 4 pi r square. So that is 4 times pi times your r is what, 2.879 square. So whatever answer we get in calculator, the square of that times 4 times. Okay, so your required surface area become 104.18. So I will consider 104 centimeter square. So for question number 15, our answer is 104 centimeter square. Now next question number 16. The square has side of length 3 and the circular arc have centers at the corner. Find the shaded area. Okay, now let us understand that this shaded area, okay, if I draw this diagonal, okay, then this part of shaded area will be your arc of segment. It is an arc of segment. So 2 times arc of segment will give you required shaded area. At arc of segment, you will get by the formula as arc of sector minus arc of triangle. So your arc of sector will be 90 divided by 360. That is fraction of angle at the center. Here this point is center. So fraction of angle is 90 divided by 360 into pi times radius. Now here radius is 3. So pi r square. So this you get area of sector. Now from here I will subtract area of triangle. So this is half times your base here is 3, your height is also 3. So half times 3 times 3. So this is one side of this shaded part. So total shaded part, if I see, it is 2 times. So let us first find out bracket, which is 90 divided by 360 times pi times 3 square minus, it is 9 divided by 2. So 2.568. Now this whole I will multiply by 2. So 5.137, that is 5.14. I will say 5.14. Okay. So this is your total shaded area, 5.14 centimeter square. 5.14 centimeter square. Now 17th question. A copper pipe has external diameter 18.8 millimeter and thickness of 2 millimeter. The density of the copper is 9 gram per centimeter cube and the price of copper is 150 per ton. What is the cost of copper in length of 5 meter of this pipe? Okay. So a copper pipe has external diameter of 18 mm and thickness of 2 mm. Density is given. Price per ton is also given. We have to find out cost of the copper pipe of length 5 meter. Okay. So 5 meters, this is your say 5 meter length and your copper pipe will be a hollow pipe with some thickness. So it is something like this. Okay, so what we do, we first find out what is the volume of copper in this pipe. Okay, and then we multiply by density to get mass, and then that mass we convert in tons, and then we will multiply by 150. That will give you your answer. Okay, so let us first figure out what is this area, this cross section area of the copper. Okay, so it is nothing but outer circle minus inner circle. So outer circle, if we see, copper pipe has external diameter of 18 mm, that is radius of 9. So pi times your 9 square, this will be your outer area, and your inner area will be pi times. Now the thickness is 2, so your radius will decrease by 2 mm. So your 9 mm radius will become 7 mm, so it is pi times 7 square. This is your area. Now this area, when I multiply by this total length, now here this area we calculated in mm. Okay, we have calculated in mm. Better I convert it in centimeter. So to convert it in centimeter, we divide the whole thing by 100, because 10 mm is equals to 1 centimeter. Okay, so we have to convert in square. So I will say that 100 mm square will be equal to 1 centimeter square. So therefore mm if square, if you want to convert in centimeter square, I will divide it by 100. So this is my cross section area, and then length, which is 5 meter, I will convert it in centimeter. It will be 500. So this is my total volume. Now this volume will be multiplied by density, which is 9. So it is multiplied by 9. So the total result which I get will be in grams. I have to convert it in ton. So gram first. To convert it in kilogram, I will multiply by 10 power minus 3, and then from kilogram to ton, again I will multiply by 10 power minus 3, because 1 kilogram is equals to 100 gram, 1000 gram, sorry, and 1 ton is equals to 1000 kilogram. Okay, so this total will give you total mass of copper pipe, and finally this whole thing we will multiply by $150. Okay, so this is what you have to find out. So let us first calculate the bracket, which is 9 square is 81 minus your 7 square is 49. This into your pi, this into your 500 times 9 times your 150 divided by your 100, and this whole into 10 power minus 6. So 10 power minus 3 into 10 power minus 3 is 10 power minus 6. So this gives you a result as what is the cost of copper pipe. So this gives you your result as 0.678 your this much dollar. A copper pipe has external diameter 18 mm, thickness 2 mm, density is 9 gram per centimeter cube, and price of the copper is rupees $150 per ton. What is cost of copper in length of 5 meter of this pipe? So this copper pipe is of 67 or 68 cents, I will say. Okay, they have not asked me to answer in cents, so I will keep this as 0.678 or $0.68. Okay, so this is approximately $0.68. Now your 18th question, 27 small wooden cubes fit exactly inside a cubical box without a lid. How many of the cubes are touching the sides or the bottom of the box? Now 27 small wooden cubes fit exactly inside a cubical box without a lid. How many of these cubes are touching the sides or the bottom of the box? Okay, so this is a three-dimensional problem. Now let me draw top view, means if I am seeing from top how it will look like. So suppose this is your cubical box from top. Now there are 27 small wooden cubes. So what we can consider, that is in each dimensions, like 27 is 3 cube. So what I can say, that in your bottom there are total 9 cubes, like this is 1, this is 2, and this is your 3, and similarly here in this direction you have 1, 2, and this is 3. In this direction you have 1, 2, and this is 3, and in this direction also you have like 1, 2 and 3. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 and this 9. Total 9 cubes. Okay, and you have 3 such layers. Okay, 3 such layers. So total 27 cubes will fit in one box. Okay, how many of these cubes are touching the sides? Now see, all these 9 cubes, they are touching bottom, except 2 cubes which are at the top of this center one. Okay, they will not touch any of the side, but rest all will touch the 4 sides. Okay, so 27 small wooden cubes fit exactly inside a cubical box without lid. How many of the cube are touching the sides or bottom of the box? So from this 27 cubes, if I remove 2 cubes which are not touching any of the side, either bottom or any of the side, I will say that 25 cubes will touch 25 cubes will touch either bottom or sides. Okay, now if they ask me how many cubes touch sides, okay, then my answer will be 24, because this one central cube which is touching at the bottom but it is not touching the sides. So your answer for question number 18 is 25. Now question number 19. Let us see question number 19. Question number 19. In the diagram, a small square is circumscribed in a circle, and a larger square is circumscribed on a circle. The area of the smaller square is 10 centimeter square. Find the area of larger square. Oh, wonderful question. Now you have given area for this inside square, which is 10 centimeter square, and you have to find out the area of larger square. For that, I need to know what is the side length of this outer square, or I need to know what is the diagonal length. Okay, so if you see, if I draw the diagonal here, the diagonal of this inner square will be your diameter of the circle. So I can say that this diameter, which I am drawing with black, this diameter have the same length as the length of this inside diagonal. Okay, now for this square, now for this outer square, if I am able to figure out what is this diagonal length, let us name this as D. Okay, so then your area for the outer square will be D square, right? And area of this inner square whose diagonal is of length D, its area is going to be half times D square, because area of square can be written as side square, or it can be written as half times diagonal 1 times diagonal 2. So your area of a smaller square is half times d square. Okay, area of a smaller square is already given to you, which is 10. So 10 is half times d square. That gives you d square as 2 times 10, which is 20. So area of a smaller square is 20 d square. D square is what? 20 centimeter square. I can say d square. Area of larger square, this is equals to d square, which is equals to 20 centimeter square. So area of your larger square here is 20 centimeter square. Question number 20. In a quadrilateral ABCD, AB is parallel to DC. In a quadrilateral ABCD, AB and DC are given parallel. So let us consider like this. This is AB, ABCD. Okay, AB and DC are parallel. And your angle DAB, this angle, and DBC, okay, your angle here, DBC, this angle, okay, this angle and this angle, they are given equal. Prove that the triangle ABD and DBC, they are similar. Okay, so to prove that two triangles are similar, we can use angle criteria. So here, if DC and AB are parallel, we can say that this angle and this angle, they are also going to be equal, right? And therefore we can say that the triangles are similar. So here I will say that in triangle ABD and triangle DBC, your angle ABD, I will say like this, angle ABD will be equal to angle D wait. This angle and this angle will also be equal. Okay, so basically what we are saying, that your angle B and your angle D, okay, they are equal because your side AB parallel to DC and angle B and angle D are alternate angle. Okay, similarly angle A and angle B is also given equal. It is given. Okay, so instead of saying triangle ABD and DBC, better if I rename, and instead of here means first triangle I can consider as triangle ABD. Now in ABD, angle A will be same as angle B. So I will start with B. I will say that triangle B. D, angle B in the first triangle is same as angle D in the second triangle. So BDC. Okay, this is better. Okay. Prove that triangle ABD and DBC. So instead of DBC, if I consider BDC, okay, then it is better to rename it as BDC. They are both the same triangles, but if I rename like this, it is better. So therefore, as the corresponding angles are equal, I will say that triangle ABD is similar to triangle BDC. Okay, your angle test. If two angles are corresponding angles are equal, definitely the third angle is also going to be equal, as sum of three angles is 180 degree. Now AB is given. AB is given 4. DC is given 9. Okay, DC I have to draw longer. DC is given 9. Calculate the length of BD. I have to find out what is BD length. Okay, so here as these two triangles are similar, I will say that AB divided by BD will be equal to BD divided by DC. So therefore your BD square will be AB times DC. BD square is equals to AB times DC. So your AB is of length 4, your DC is of length 9. This is your BD square, and therefore your BD will be equal to 2 times 3, which is equals to 6. So BD is 6 centimeter. Okay, next question. A rectangle 11 centimeter by 6 centimeter is similar to a rectangle 2 centimeter by x centimeter. Find the two possible values of x. A rectangle 11 centimeter by 6 centimeter. So this is 11 and this is 6. A rectangle 11 by 6 is similar to rectangle 2 by x. So there is another rectangle whose say one dimension is 2, other dimension we don't know, 2 by x. So this x we can find out, find the two possible values of x. Find the two possible values of x. Okay, this is a similarity problem, okay. So similarity problem, then in that case what we can say, that there are two possible cases. One is 2 centimeter which we are considering is something like this. Okay, this is 2 and this is x. The other case could be this length will be 2 and this length will be x. Okay, so as they are similar, what we can say, we can let us consider this as x1, this as x2. So in the first case I can say that 6 divided by 2 will be equal to 11 divided by x1, or I will say that 6 divided by your x instead of x1 x2, as I am using word or, I can say that x. So 6 divided by 2 is equals to 11 divided by x, or 6 divided by x will be equal to 11 divided by 2, and therefore here I have x is equals to 22 divided by 6, or x is equals to 12 divided by 11. Okay, so therefore your x is equals to 22 divided by 6, it is 3.67, or your x will be 12 divided by 11. So 12 divided by 11, it is 1.09. it is 1.09 centimeter. Fine. So the value of x is 3.67 centimeter or 1.09 centimeter. Now next question. In the diagram, triangle ABC and EBD are similar, but DE is not parallel to AC. Given that AD is equals to 5, BD is equals to 3, so this is 5, BD is given 3 and BE is given 4, we have to calculate the length of BC. Okay, so now it is given that these triangles are similar, and also it is given that this DE is not parallel to AC. So as DE is not parallel to AC, definitely your angle E and C are not equal, and your angle D and A is not equal. Angle B definitely is common. So what we conclude from here, that as D is not same as A, then definitely it is going to be same as C. Okay, so I will say that from given condition, given information, your angle D in the smaller triangle will be same as your angle C in the larger. Your angle E in the smaller triangle will be equal to your angle A in the larger triangle, and your angle B is same in both the cases. So you will say that triangle DEB will be similar to triangle CAB. This is by angle criteria. And therefore, you will say that your DE divided by your CA will be equal to your EB divided by your AB will be equal to your DB divided by CB. Okay, now let us put the values. DE unknown, CA unknown. Okay, so forget about this ratio. EB is given 4 and AB is given 5 plus 3 8 will be equal to DB. Now DB is given 3 divided by CB is 4 plus EC. Okay, so this 4 divided by 8 is 1 divided by 2. Okay, as here the ratio is half, here this is going to be half, means I can say that this 4 plus EC will be equal to 6, and therefore your EC is going to be 2. Now I have to calculate BC. So your BC will be equal to 4 plus 2, which is equal to 6. So your length of BC is going to be 6 centimeter. Wonderful question. Now question number 23. The radii of two spheres are in ratio 2:5. The volume of smaller sphere is 16. Calculate the volume of larger sphere. So your V1 divided by V2, okay, will be 2 divided by 5 the whole cube. Actually, if radius are in ratio 2:5, their volume will be in the ratio of 2 divided by 5 the whole cube, as the expression for your volume V1 will be equal to 4 by 3. Okay, you can do that. It is 4 divided by 3 times pi r1 cube, and this is 4 divided by 3 times pi r2 cube. So this 4 divided by 3 pi cancels, and you have R1 divided by R2 the whole cube, which I have written here 2 divided by 5 the whole cube. Now a smaller volume is given 16, so 16 divided by V2 will be equal to, here 2 cube is 8 divided by 5 cube is 125, and therefore your V2 times 8 will be 16 times 125. That gives you your V2 is equals to 16 times 125 divided by 8, which is 2 times 125, it is 250. So 250 centimeter cube is the volume of larger sphere. Now question number 24. A car is an enlargement of the model, the scale factor being 10. If the windscreen of the model has an area of 100, find the area of the windscreen of the actual car. So your area of actual car, area of car divided by area of model will be, as the scale factor is given 10, so it is 10 divided by 1 the whole square. Okay, linear scale factor is given 10. So area will be in the ratio of 10 divided by 1 square. Area of model is given 100. So your area of car will be, it is 100 times area of model, which is 100. So this is 10,000. 10,000 centimeter square is the actual area. Now this I have to convert it in meter square. So 100 centimeter is 1 meter. So I will say that 1 meter square. If the capacity of the boot of a car is 1 meter cube, find the capacity of the boot of the model. Now here, ratio of volume of car divided by volume of model will be in the ratio of 10 divided by 1 the whole cube. Now this volume of car is given 1 meter cube. 1 meter cube means 100 centimeter the whole cube. Divided by volume of model, we don't know. Here it is 10 divided by 1 the whole cube, which is equals to 1000. Okay, so therefore volume of model will be equal to 100 times 100 times 100 divided by 1000. Okay, this will give you 1000 centimeter cube. So volume of model is 1000 centimeter cube. Nice question. Okay, so by this we finished all our review type of questions. I hope you are with me. You understand each and every questions. In many of the problems, I have not explained you the concept in much depth. I assume that you know all those things. As we are doing revision exercise, you must have already done all the previous exercises. Okay, but if still you have any query, any problem, let me know. Thank you.